Taking a look at our last section on the first page, the solving, we are being asked to solve two quadratic expressions. And I know that they're quadratic because in the first one, we have a factored form expression. If I were to multiply those two binomials together, I would find that I would get an x squared, because x times 3x is 3x squared. So since I have a quadratic, there are a couple things that have to be true for quadratics in order to solve it. First, it has to be equal to 0. Second, it has to be in factored form. So I'm looking at this expression, and I notice that it meets both conditions. It is equal to 0, and it is in factored form. So what I'm going to do is I'm going to break it into its linear pieces. If I were to graph this and that separately, I would get a line, right? So, and now it's time to just solve. What will I do on this side of the equal sign to get x by itself? Well, what's the opposite of subtracting 7? Adding 7. So I guess I'm going to have to use my finger again. Adding 7. What I do to one side of the equal sign, I have to do the other side. So I get 7 is equal to x. On this side, the opposite of adding 5 is subtracting 5. And so I get 3x is equal to negative 5. And divide by 3, because the opposite of multiplying x by 3 is dividing x by 3. So I get x is equal to negative 5/3. And it's okay to keep it as a fraction. Fractions are numbers too. You don't need to convert everything to decimals. And there are my two answers. So in essence, I have a parabola that crosses, there you go. So this point of intersection would be negative 5/3, and this point of intersection would be 7. And that's why you have two answers. In my next question, number 21, same thing. We have to have it equal to 0, and it has to be in factored form. So I'm going to clear off my board, give myself some more work or space. And right now I'm not equal to 0, so I need to move that 2x. So what's the opposite of positive 2x? Negative 2x. So I would get 3x squared minus 5x, well, to the third, my bad, squared minus 2x is equal to 0. So then I have to go through my factoring checklist. I need to find a greatest common monomial, because I do have a greatest common monomial in this case. X goes into all of them. So I can factor out my x. 3x to the third divided by x is 3x squared, minus negative 5x squared divided by x is negative 5x. Negative 2x divided by x is negative 2. And that's still equal to 0. And so I need to now factor this as a binomial pair of factors. And I know that 3 times 2 is 6, and 6 minus 1 is 5. So what do I need to multiply together to get 3x? Well, 3x squared. 3x times x would give me 3x squared. And to get a negative here, I know I have to have one positive and one negative. And I may have had that switched. So I will do this again. Let's say I have 3x, or minus, and then x, and plus. And so I know I have to have 3 times 2. So then negative 2 times 1 would be negative 2. And now let's see if my linear term works out. 3x times negative 2 is equal to negative 6x. Oh, this is looking good. 1 times x is positive 1x. You add them together and you get negative 5x. So I know I have it correct. So in factored form, I have x times 3x plus 1 times x minus 2. And this is all equal to 0. So at this point, I'm going to break it into its pieces, maybe. And if I'm multiplying three things together, 1, 2, 3, and getting a product of 0, it means one of these things has to be equal to 0. So let's set each one equal to 0. And this one's already set. Well, right away I see that x is equal to 0. So there's one of my zeros, one of my x-intercepts. In the next one, well, let's solve it. Minus 1, minus 1. So we get 3x is equal to negative 1. Divide by 3, divide by 3. And I get x is equal to negative 1/3. And then finally, add 2, add 2. So I have x is equal to 2. So there are my three answers. And if I go back to the idea of x-intercepts, if I draw a grid, I will have something that looks a little bit like this. Where this point here is negative 1/3, this point here is 0, and this point here is 2.